So welcome to this talk. This is the second part of my introduction to Delphi MVC framework, which is particularly suited for talking about data, business logic, and how to produce APIs able to handle data and business logic. I'm always the same. I'm Daniele Teti. How many of you already attended my first part of this talk? Okay, good. Let's start our discussion about the MVC framework on MVC Active Record. But before that, let's talk about a bit about the business logic. What is the business logic? Business logic or domain logic is the part of the program that encodes the real-world business rule that determine how data can be created, stored, and changed. Okay, we agree on that. But this is the piece of the system which solves the customer needs. He pays us to implement business logic, not just to managing data. We have to manage data following the logic of the business. So, business logic is what makes our system useful for the customer. Otherwise, we are just doing gymnastics to do some data in and out, in and out, in and out. There is no additional value. So how to handle, if the business logic is so important for us, because it's important for our customer and our user, how to proper handle business logic? Does your system have a single point where business logic happens? Single point. Does your system have a single point to handle business logic, or is it scattered under data sets, buttons, actions, forms, UI, blah, 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 blah. So, obviously, in documentation, there is a lot of books, articles, talks, talking about how to handle business logic, because it is real important. It's more important than any kind of technology. Okay. One of these patterns, which is not new, it is not the better, it's just one of that. One of the design pattern to handle business logic is called Active Record. Active Record is a software architectural pattern that stores in-memory object data in a relational database. The name is active because there is also the passive. No, it's just active. It was named by Martin Fowler in its great book of 20 years ago, named Pattern of Enterprise Architecture Application. Pattern of Enterprise Application Architecture. It is really sad, but many users know Active Record pattern just because when Ruby on Rails exited some years ago, there was an Active Record stuff which does great thing. Wow, Ruby on Rails invented the Active Record. No. Active Record is at the same pattern, and we can do Active Record in any language. The interface of an object conforming to this pattern includes functions such insert, update, delete, plus some properties that correspond more or less directly to the column of the underlying database table. So as a first approximation, you can think about an Active Record object like an in-memory version of a record of a table. As a first step, this is not like this. Just as a first step, you can think about it. So each field of the table become a property of the object, and each record of the table become an instance of the object. Okay. When you have to issue a select on the database, these methods are implemented using finder methods. This finder method will be another class or just static methods on the same class. And this pattern, it is really popular and available really many libraries for a number of languages. Entering MVC active record. MVC active record is the implementation of the active record design pattern included in the MVC framework. MVC active record is a really thin layer of abstraction, object-oriented abstraction, because, parentheses, data sets are object, but if you use only data set, you are almost use procedural approach, okay? So it's a thin object-oriented abstraction layer over FireDuck. It is designed to be simple, just like the whole DMVC framework, just to be simple. And you can be productive in minutes, really. It is quite general, but it is very useful for CRUD-oriented applications. So the MVC framework uses it to provide automatic API generation for your entities. Once you have defined your entities, you just can publish it, and you have an API. It is not a replacement for a full-flagged object relational mapper, but in most cases it is good enough, and in the remaining cases it's simple to reach the same level of details of a norm could be. It currently supports without changing anything, apart specific cases, supports PostgreSQL, MySQL, MariaDB, Firebird Interbase, SQL servers, and SQLite. So this is how an entity is declared. It's a normal PODO, which stands for plain old Delphi object. It seems an extinct animal, but it's a PODO, it's not Dodo. It's a class which inherits from TMVC active record, and which is instrumented using RTTI attributes. As you can see, there is the MVC table attributes, which defines the name of the table where this class must be retrieved, persist, inserted, updated, and so on, and MVC table field, which defines the mapping between the class attribute, the class instance attribute, and the field of the table mapped by that class. So in this case, we have the field FID, which is persisted in the field ID of the table alt articles, the field F description, which is persistent in articles.description, and so on. Any mapping can have a rich description attached to it. For example, the field ID is defined as primary key and auto-generated. As you can see here, we are using some strange type, this nullable int32. What is? The MVC framework provides nullable types, which can be used also in non-DMVC framework project. What is a nullable types? It's a simple types that can be null. As you know, if I try to create an object, the object can be assigned or dangled pointer, but let's say assigned or nil, okay? An integer can be an integer, cannot be null, because it represents something that cannot be null. It's a simple value, it's not a pointer, okay? Nullable types allows to define this concept, the concept of null, also for simple types. These are the methods available for any kind of nullable type defined by the MVC. The name is name of the types, the base types, with a prefix with nullable. So you have nullable integer, nullable int32, nullable int64, nullable string, nullable tdate, nullable blah 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 blah. Each nullable type has a set of method and property, has value, is null, clear, set null, value or default, which returns the value if present, or a default value for that type. For instance, an integer, a nullable integer can return the value stored by internally the nullable integer, or the default for the type, which is 0 for an integer, okay, or empty string for a string, and so on. Okay, let's see a small demo. In the folder, in the samples folder, in the MVC framework, you have the Active Record Showcase. Just to show that it can be used for any kind of project, this showcase is a VCL application. Let's see what is behind this button, which is the CRUD. It is readable like this? No, okay. Let's zoom it. Okay. Here we have a simple CRUD test. So you have this tmvc active record.count, which retrieved the count for this instance. We are not talking about table, we're talking about classes. Counts, or you can just create a customer and then set some property and then call insert or store, and all the auto-generated fields are automatically filled, and you have just inserted a customer. Questions for you. Which kind of database is behind it? We don't know. Ignorance. And in this case, ignorance is a good thing. Because if you don't know what is behind, you don't have connection with them. We don't depend upon it. So you can change it. And this is actually what we do in a moment. Then this is for create record. This is for retrieve instance by primary key, and then update something, and then update it. Also, we could have an object. We can fill the object by load it by primary key, update something. It's completely Unicode enabled, clearly. Or we can delete it. What about declaration? This is more or less what we see in the slide. This is the test for all kind of database, if there are sequences, if you don't have how to increment. But the declaration is really the same. This class is mapped on the customer. This is the mapping for the field, and that's it. There are the nullables and so on. So let's see this stuff working. We can choose one of the database. The code is the same, really the same. Just pick, for example, Firebird, and then CRUD. That's it. The code is what we see before. This is for the CRUD part, which is cool, yeah, but not so stunning. Let's talk about events. Active Record defines a number of events in the, let's say, general term, are not Delphi events, okay? Events are the hook that you can manage to handle business logic, for example. So define a number of events and call them accordingly with the object lifecycle. When it's read by the database, just before insert, just after insert, just before update, just think about a sort of trigger, of table trigger, but better, okay? You can hook your persistence and or business logic in the object itself. And events are useful also to implement delayed loading, for instance. You can get the details of a master detail relationship only when someone actually asks for the details and not up front. You can handle relationship, cascade update, or some intelligence on your object. For instance, send an email or new order when a new order is persisted. And please do not add dependency in the storage layer, because here we are working, we are talking about business logic. All the technology, which is the database, the server, is not this is not the place where you have to plug this kind of dependency, okay? So these are the events on validation, which is called everywhere before persist object into database, or after load, which is self-explained, before load, before insert, after insert, before update, after update, before delete, after delete, before insert or update, and after insert or update. Let's see also here an example. Let's go under the button validation here. Here we have customer with logic, which inherits from the customer. Don't have to redefine attributes on the field level because it has been defined into the customer. In the after load, we define a new value for the property is located in Rome, because for some kind of business logic, I have to know if an instance is located in Rome. If a customer is located in Rome, it is a kind of business logic. Before insert or update, here I translate all company name and city in uppercase. And on validation, which gets also a parameter, which tells me if I am inserting, deleting, updating, blah, blah, blah. And here I can do some check. If company name, value or default is empty, or city is empty, or code is empty, company name, city, and code are required. In my main code, I don't do anything. I create an insert, then retrieve the just inserted object, and try to put code as an empty string. And I get an exception. This means that in every place of the program, of our project, this object is used in any place, this rule is enforced. I don't have to remember, so when a customer is saved, I have to check this, but I can insert customer there too, so I have to check there. So where is the business logic? Scattered all over the world. This is what makes software difficult to manage, because the complexity level reach a point where you say, I have to rewrite it. Did you ever listen this word? How we should better to rewrite all? It's a problem, huh? Because we do a lot of effort to reach a point where we have to throw it all. It's a problem, huh? We have to manage the complexity. Also, the entities can be inherited from one from the other. For example, in this case, we are handling relations. After loading the customer X, in this case I want to load directly, I can load all the order for this customer. This could also be delayed. In this case, it's just after loading. In some cases, you have to differentiate between CRUD-related classes used to manage entity data, so insert, update, delete, and read-only entities. For example, summary date, graph data, master dates. So you have to differentiate it. If you have, for example, let's say this, also in a VCL application, you have a search panel when you can start to write something to filter, then search, a dbGrid sort of, is filled with some summary data. Let's say customer name, orders number, value of all the orders of the last month, and so on. Is each line of this dbGrid an entity which handle logic? Is just a reading logic. Okay, we are not writing there. So we can just use SQL to execute it on the database and then map the result set, on a summary object. A summary object must be read-only because it doesn't make sense persist one row of that DB grid, okay? Because it's an aggregation, it's a join with 20 tables, okay? In this case, I have to handle the read-only entities. We can handle it using the MVC entity action attributes. Let's see the example. Read-only entities, as is. This one is a read-only customer. Why? Because in the entity action, have only the EA entity action retrieve. So this cannot be created, deleted, blah, 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 blah. Also, SQL is good for all the complex things. But when it's not so good, when you have to create by hand always the same SQL. Insert into blah, 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 update, blah, 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 blah. Or the simple select, for example. In this case, for the select part, can be used RQL. What is RQL? RQL is a resource query language, and is a query language designed for it to be used in URIs. It's a standard in the URIs of the website, APIs, and so on, using a functional syntax. The MVC framework includes RQL filters, limit, and sort clauses. Applied, and this can be applied only to single entity. RQL can be seen as a set of nestable operator and is designed to be simple and safely transferred as a parameter on the URI. Also, RQL, as implemented in the MVC framework, has its own compiler, which is a transpiler. But it takes the RQL and knowing the type of database where the object is currently connected, he can translate it to the correct SQL for that database. So there is no possibility of SQL injection. This is the reason because you can put it safely on the URL. These are some operators. There is the sort, limits, and or, less than or equal, greater than or equal, not equal, contains, blah, 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 blah. If you want to play a bit with RQL, there is a sample named RQL to SQL, which show how RQL clause is, how each RQL clause is converted in a specific SQL for specific database. For instance, in this case, for Firebird, this is converted in this way. For MySQL, which doesn't have containing, is converted in this way. For Postgres, which has I-like and I-like operators, is converted in this way. The best way for each kind of database. And this works clearly for all database we're working on. Let's see how it looks like in our code. This is a query in query sorting and limit in RQL. Check. It is just a set of functions. You have AND, and then inside AND, which is variadic, you can put a lot of parameters in the AND. You can put other function, for example, equal, or other complexity inside here. And this works for any kind of supported database. You have a lot of methods which uses RQL. You have, for example, select RQL, you have select SQL and select RQL. And this is completely safe for the SQL injection attack. So let's see how to create a complete API using Active Record. The last time we see how to create an API using dataset. Now that we know Active Record, let's try with Active Record. Here we have defined all our entities with logic. In this case there is no logic, but it's the case. And this is the controller. This is all the controller. That's it. For a create, do you remember at the first part how code you have to write, how much code you need to write to create an insert with all the safe parameters, blah, 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 blah. Customer, customer, deserialization, directly customer.insert. Is literally one line. Also in this case to get the single one, this is to automatically enable also the querying with syntax, with RQL syntax that also the user could write, because it doesn't break nothing. There is no problem for SQL injection, blah, 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 no problem. It's safe. And this is, for example, to create a bulk insert. Just allow the clients to send an array of customers, start transaction, because the operation must be atomic, and then loop on customer, insert, insert, insert. That's it. There is a mechanism inside to define which is the current connection, and the current connection is handled transparently for the user. You have just to define the name of the further connection, and each thread can get its own connection without problem. So it's inherently thread safe. But let's see also the multi-thread sample. Where is? That's it. You have this active record connection registry, which for each thread, there is a map inside, and for each thread it says which is all the connections available for each thread. When you define a default connection, any object created inside that thread, in the context of that thread, will use that connection. If you want to use another one, just switch connection, create the other object, and needs to connect to the other part, and that's work. You can do also a very easy data pump, because you can load object, switch connection, persist. That's it. Okay, there is also, consider that now relational database are not only storage for simple data in table. There is also support for JSON, JSONB, XML, and blah blah. You just have to map to the correct field. For example, here, this is how it works on Postgres. You just have to see, listen, this string is saved in a JSON field or a JSONB field or in an XML field and so on. And you can use also the specific function for JSON, XML, and so on in the query. Often is useful in big system or not so big system to create some standard filtering or partitioning in your business data. For example, you could have the concept of good customers. What does it mean? I don't know. They are good customer because one time you talk with a business and they told it because this is a good customer because I don't know, has a rating with 4 or better. Okay, that is an invariant in your system. This is defined as a good customer. Or admin users. You have to remember that a user is defined as an admin if, I don't know, there is a field which defined is as a super user. Or European customers. Or active user. All of these defined definitions relies on a sort of filtering. When a user is active, when there is a field, blah, 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 in this way. When there is a field, is active equal 1, for example, okay? Why don't define this invariant directly on our entities? So that you can just get all the bad customer, for example, or all the admin user or non-admin users, without remembering what does it mean admin user, which this field must be. This allows us to slice our table in a functional way. So this is the automatic filtering. This is our plain definition for a T-customer class. And here we have the T-good customer and T-bad customer definition. In the MVC table attributes, just define an arbitrary complex criteria expressed in RQL, which define the criteria to apply to any reading operation for that class. So in this case, you have a good customer. If tomorrow change the criteria which defines a good customer, just go here, change the RQL, and that's it. This is the automatic filtering and is attached to all the methods able to read something. So where generic, get first by where, get one by where, delete all, and so on. This is a sample. We don't have too much time to show all, so I just show this one. Let me check all the good customer. What does it mean? It's a good customer. Let's take all the good customer and sort them by company name. What you say there in the sort is not the field name, because if that company name was the field name, we're talking about the connection of the structure. We know the structure of the table, the name of the field. This is the attribute name. So it's the attribute that the T-good customer class has. Obviously, you can do anything there. Also, about the automatic filtering, there are limits. Because automatic filtering, so it doesn't prevent to change the criteria used by query. And this is also a feature, because you could get a bad customer which just paid all the stuff that should have paid and promote to good customer. It's just filtering. Sometimes we need a stricter check. So we could think about the table and just slice it, partitioning horizontally. Partitioning. There is another attribute which is called MVC partition, where you can define the partition clause. The partition clause acts like the default filtering, but enforces the criteria even for the whole CRUD operation. It's just like another table. If some of you know how PostgreSQL works for the partitioning, it works in the same way. So you can say the customer up to, I don't know, the customer with this region must be written in this table space, for the other region must be written in this table, and this other region in this other table. From the user point of view, you just select from one table. Okay? In this case, we are slicing horizontally our tables to define new entities. In this case, the criteria must be equal something, cannot be measured than, like in the case of the filtering. So there is a parser, this is not a compiler, there is a parser there which uses this syntax, this partition syntax, where there is the field name equal data type of the field. Where is the cursor? Here? No, it's here. Data type of the field in parentheses, and then the value, semicolon, other criteria. So you can see, you can write something like this. So in this case, I sliced my table for New York-based good customer, which means city as a string must be New York, and rating as an integer must be 5. So you can have something like this for the entities. And these are all entities, completely new entities, but mapped on the same table. Also, there is a very common problem. We talk about this one with someone these days. The merge problem. The problem is, you have a list of customers in a table, and the users send a JSON array with another list of customers, which can be the details of something, or just a list for a bulky insert. I don't know. You have a list, and the user sends to you an updated list. This list that the user sent to you represent the changes required to the customer in the table. Some of them must be inserted. So the client is sending a new customer. Some must be updated, and some other must be deleted. It's quite complicated to figure out how to do things and when. What's the best and correct way to get the job done? Triggering all the business logic attached to the object. Because I could say just an update, and but you are bypassing all the business logic. And that's not good, clearly. This is an implementation of the unit of work design pattern, which allows to do that in a quite simple way. You can just pass to the MVC active record. The method is called merge. It's a generic method. You have to define which kind of class the lists are based on. Customers, which is the current state, and customer changes. The output is an instance of unit of work. This unit of work know what must be inserted, what must be updated, and what must be deleted. For each one, you can intervene to customize the specific action, because there is an anonymous method to the apply method that say, hey, I'm just trying to insert this one, is okay? I'm just trying to update this one, is okay? And so on. And you can see, and you can check what you want here. Also, having this entity so aware of the business logic, because they are the place where to put the business logic, we could also put this entity in an API and just expose them. Would be cool. Yes, the MVC active record controller is for this is designed to be for this reason. The MVC active record controller is just another controller, so it's not complex to do. Just plug it, allows to expose your MVC Active Record entity through the API. It is integrated with the MVC authentication framework, with all your authentication mechanisms, JWT, OAuth2, all the things are in place correctly, and allows also to handle the permission, okay, based upon the user connected, let's say, logged in. This is the API which is automatically exposed by the Active Record controller, which is not a standard, because REST is not a standard, is an architectural design, but this is more or less a standard de facto, okay? You can also disable single elements about the exposing. This is what the MVC Active Record controller allows to us without any work, without any. And this is done here. Let's check. This is also useful because exists a tool which is called Entity Generator, which allows to automatically generate the entities starting from a database, which is the first version. Then you have to work, then inherit, adding business logic and so on. But it's the first version. You can also declare classes as abstract. And in this way, you can just, for example, call it entities, generate code, that's it. And here, you have the generated entities. Plug this one in the Active Record controller, and you have exposed your data and business logic safely to the end user through a RESTful API. There is a customer which had something like 1,500 tables, and just, I want to access it with an API. It's quite complicated, but with a bit manual work because the unit was too big, but it works. So how this works? Here we are. Just you have to declare entities here with all your business logic, and then plug the Active Record controller. That's it. And all is exposed. And this is the path where all the entities are exposed. Let's go on. Something could change. If something change, I'm forced to remove all the things that changed and then re-implement by zero. If, for example, one method, one retrieve is changed, no, because there are the entities processors. The entity processor are something that can be hooked to a specific path to change the default behavior. So you can start with the plain behavior and then configure each one. About the roadmap for 2023, at the time I come back to Rome, there will be released the 3.4.0 Neon with the .env support with an updated wizard. And for the end of the year, we do the major version release, changing middleware and filters as a Spring Boot and Express and Node.js does. We will change, it's not change, it is another option for the high-performance TCP library, which is not based on Indy, but this is just for the built-in server. And also the action can be functions as well, and not only procedure. If you want to be a supporter, this is the Patreon channel. This is the official guide, where is named also the stuff related to MVC framework. And are there any questions?
I was asking, which is the speed? How is the speed of Active Record compared to traditional modifications and updates on the table?
It is quite good. It is not the same because there is obviously a layer on top, but it is quite good. Quite good. I'd say that maybe you lose for specific. In the worst case, I think you could lose 10%, 15%. Okay. So I usually do this. Start using Active Record everywhere. Then, if there is a problem, I can try to change to just go to the bare metal, but only if you have the numbers that justify such actions. Okay, because in the grid, in the majority of cases, it's not a problem. Okay, a normal ORM is way more slower than this layer because it's really thin. Okay.
Thank you very much for your talk.
Thank you.